Imagine a substance that makes up 85% of the universe. It surrounds us, shapes galaxies, holds the cosmos together. And yet, it's invisible. We can't see it, we can't touch it, we can't even feel its light. And still, we know it's there. But how? And why does it remain one of science's greatest enigmas? The story begins almost a century ago. In 1933, Swiss astronomer Fritz Zwicky turned his telescope to the Coma Cluster, a massive swarm of galaxies drifting through the night. What he found was impossible. The galaxies were moving far too fast. By every law of physics, the cluster should have flown apart, its galaxies scattered into the void. And yet, they stayed together, bound by something unseen. Zwicky stared at his calculations and reached a radical conclusion. There must be hidden mass out there, a kind of invisible matter holding everything in place. He called it dunkle Materie, dark matter. But his colleagues laughed. An invisible universe sounded more like science fiction than reality. Zwicky was ridiculed, dismissed, ignored. Yet he had glimpsed a truth too large to erase, and in time, the universe itself would confirm it. Decades passed. More astronomers began to notice strange patterns. In spiral galaxies, stars at the edges were moving too quickly. Normally, gravity weakens with distance, just as outer planets like Neptune orbit far slower than Mercury. But galaxies broke the rule. The stars at the edge refused to slow down. It was as though something unseen was pulling on them, an invisible hand. That hand was dark matter, but the mystery did not end there. Einstein had shown that gravity bends light, curving the path of photons across the cosmos. Astronomers found that when they studied distant galaxies, the bending of light, known as gravitational lensing, was far stronger than visible matter alone could explain. It was as if hidden giants lurked in the darkness, twisting space-time like glass lenses. Then came the cosmic microwave background, the faint radiation left over from the Big Bang. When scientists mapped its tiny fluctuations, they discovered something extraordinary. The fingerprints of dark matter imprinted across the universe itself. It wasn't just hiding in galaxies. It was everywhere, a silent presence shaping the cosmos. But one piece of evidence was especially striking. In the early 2000s, astronomers observed the Bullet Cluster, two massive galaxy clusters colliding. What they saw defied simple explanations. The hot gas, which contains most of the visible matter, smashed together and slowed down. But the gravity, the hidden mass, passed straight through, unaffected. It was a cosmic smoking gun, proof that dark matter was real. By then, the case was undeniable. And yet, the true nature of dark matter remained an unsolved riddle. So what exactly is it? A new particle? A hidden field? Something stranger still? Scientists proposed candidates. One was the WIMP, the weakly interacting massive particle. Heavy, invisible, and barely detectable, WIMPs became the leading contender. Another was the Axion, a feather-light particle that could flood the universe in unimaginable numbers. Others suggested entire families of dark particles, interacting through forces we don't yet understand. But none have been found. We know what dark matter doesn't do. It doesn't shine. It doesn't reflect. It doesn't absorb. It doesn't interact with light at all. To us, it's a ghost with weight, an invisible shadow keeping galaxies from tearing themselves apart. But science is never without dissent. Some physicists argued, what if dark matter doesn't exist at all? Maybe the problem isn't missing matter. Maybe the problem is gravity itself. This led to MOND, modified Newtonian dynamics. A radical idea. Perhaps Newton's laws of gravity simply don't work in the weak gravitational fields of galaxies. It was bold, elegant, tempting, and for a while, it seemed promising. MOND could explain the rotation of galaxies, but it struggled elsewhere. It could not explain gravitational lensing. It failed with the bullet cluster, and it collapsed completely under the evidence of the cosmic microwave background. Piece by piece, a MOND unraveled. The invisible universe remained, and so began the greatest scientific hunt of our time. Deep underground, in vast caverns shielded from radiation, enormous detectors wait in silence. Tanks filled with liquid xenon, wires cooled to near absolute zero, all waiting for one thing: the tiniest collision between a dark matter particle and an atom of ordinary matter. Just one spark in the dark. At CERN's Large Hadron Collider, particles are smashed together at near light speed. Among the debris, scientists look for energy that vanishes without a trace, possibly escaping as dark matter. Meanwhile, space telescopes scan the heavens for indirect clues: unexpected gamma rays, subtle distortions, hidden fingerprints of the unseen. And yet, silence. No confirmed detection. The shadow remains elusive. But here's something important. Dark matter is not the same as dark energy. Dark matter pulls. It holds galaxies together. Dark energy pushes. It drives the universe apart, accelerating expansion. One is cosmic glue. The other is cosmic fire. Together, they dominate the universe. And we understand almost nothing about either. No wonder science fiction has embraced dark matter. In stories, it becomes the ultimate power source, the fuel for faster-than-light travel, the secret weapon of alien civilizations. In truth, it is none of these, but as a symbol of the unknown, terrifying, limitless, full of possibility. Dark matter captures our imagination like nothing else. But imagine, just for a moment, what if tomorrow we finally discovered what dark matter truly is? Cosmology would be rewritten overnight. We would finally understand how galaxies formed, why the universe looks the way it does, and perhaps even glimpse the existence of other universes beyond our own. And the technological implications? Beyond imagination. If dark matter is a particle, could it be harnessed? Could it reveal new forces of nature? Could it open pathways to higher dimensions? Speculation, yes. But remember, every leap in science once seemed impossible. Atoms, relativity, the Big Bang, all dismissed as madness before becoming truth. For now, dark matter remains a shadow. Without it, galaxies would fall apart, stars would scatter, the universe itself would unravel. And yet, we cannot see it, which leaves us with a haunting possibility. What if dark matter doesn't exist at all? What if every clue, every observation has been a mirage? 85% of the universe remains invisible. We live surrounded by a cosmic secret, hidden in plain sight. So what do you think? Is dark matter truly out there? Silent, invisible, powerful? Or are we standing at the edge of a deeper revolution in physics? Share your theory in the comments. And if you love exploring the mysteries of the cosmos, subscribe, because the universe still has secrets waiting to be revealed.